Hello, Calculus kids. Here is section 3.1, the beginning of Unit 3, on the chain rule. And the chain rule is actually a really important derivative rule in the midst of what we learn. So this is going to come up over and over and over again. So it's a really important lesson. But it all goes back to the days of, remember this from pre-calc, f of g of x. These are composite functions where you have functions within functions. And this was, we would call this FOG back in our day. Right, that's another way that you can look at it. So the whole idea of a composite function is that there's a function inside another function. Inside, if I can spell. Another function. Okay, so if I'm looking at this and I think about this as an f of g of x, and I have something like this, sine of x squared. If I look at it, the inside function is the x squared, so that would be my g of x. And the outside function, my f of x, is the sine of x. So that when I take this x squared and plug it in here for the x, now I've got sine of x squared, which is what I wanted. How about this guy? I have two functions. One of them is a square root and one of them is a natural log. So which one's which? I have an f of x function and I have a g of x function. I'm taking the ln of x and I'm putting it into the square root. And so that's how that guy would break apart. But how about this one? This one I actually have three functions. So I'm going to have an f of x, I'm going to have a g of x, and I'm going to say it's an h of x, my third function. So you start from the inside and work your way out. My inside-most function is the 5x, and that's being put into the sine of x, and that's being put into the cosine of x. So again, you work from the inside out. And so here's the rule for derivatives of composite functions, these composite guys. You take f prime of g of x, and you multiply it by g prime of x. So what that kind of means is you take the derivative of the outside function and multiply it by the derivative of the inside function. Generally speaking, that's what you're doing. All right, so let's try some and see. Number one, if I look at this first one, I've got a power going on, right? I've got this quantity being raised to a power. And if I want to find the derivative, I'm going to take the power and bring it down, just like the regular power rule says. So it's the power, and then I take the grouping to one less power. It's going to be to a cube. But here's where the chain rule comes in. Now I need to take a derivative of what's inside. So I took the derivative of the outside part. Now I need to multiply that by the derivative of the inside part. The derivative of x squared is 2x. The derivative of a 5 is 0. And then it's just a matter of making it pretty. So I have 4 times 2x, that's going to be an 8x. And I have a quantity that's x squared minus 5 quantity cubed. So number 2. I have a square root. We don't do square roots. we usually change them into powers. So here I go. I've got 4x minus 3 that's being raised to the 1/2 power. That's my regular function. And now I can apply the power rule just like I just did. So the power rule, power comes down, g prime of x. Power comes down, I have a half. I take the grouping to one less power. That would be a negative 1/2. But then I need to multiply by what's inside, the derivative of what's inside. Derivative of 4x is 4. Derivative of negative 3 is 0. And then again, I pretty it up. So here I go. I know I have a fraction because I've got a negative exponent. Half of 4 is 2. And this being to the negative exponent goes in the denominator. You can write it as a square root, or you can write it as a power of 1/2 in the denominator, and that's what it looks like. Number 3. I would rewrite this. The square is in the middle of this thing. Another valid way to write this is to call it the sine of 5x squared on the outside. That's easier for me to see how the power rule will be applied to it, so I tend to like this notation better. They're all the same though, they mean the same thing. H prime of x, the 2 falls down in front. The group goes to 1 less power, goes to the first power. Now watch this, times the derivative of what's inside. Well, the derivative of sine is cosine of the same angle, but then I need a third thing. I need the derivative of the angle, and that's a times of 5. Some people might forget that 5 at the end of this whole hot mess. So if I clean it up, I have 5 times 2 is 10, and then I have a sine of 5x and a cosine of 5x. All right, we'll try another. This one you can see it's a repeat, so I'm going to show you 2 different ways that you could do this. Let's just try it the normal way we just have been doing the others. I have 2 functions, an ln function and an x cubed function. So I'm going to do my rule. The rule says take the derivative, y prime, of the ln part. Well, the ln part is 1 over whatever it is, x cubed in this case. But then I need to multiply that by the derivative of the x cubed, which is a 3x squared. And then I can simplify that because I have 3x squared over x cubed. My x has become just an x on the bottom, and Mr. 3's hanging out there. So 3 over x. But how about if I think of this as using pre-calc rules for logarithms? I know you all love them. But here's the story. This would be equivalent to y equals, powers are allowed to come down in front. That would be an equivalent form. And so let's take the derivative of that. That takes away the whole chain rule thing, because the derivative, well, the 3 just stays a 3, and the derivative of the ln of x is 1 over x. And if I have 3 times 1 over x, I get that same answer of 3 over x. So if you can sometimes apply, if you remember them, the logarithm rules, it makes it really easy and avoids having to go through the chain rule. Number 6, I would highly suggest you write small. This guy's going to take a lot of doing. You can see him, he's pretty beastie. So I'm going to come out into my margin and start him because I need some space. All right, f prime of x. The predominant rule is the power rule. So the power is going to come down in front. My grouping is going to go to 1 less power. But then I need to take the derivative of what's inside. Now you can see, if I think ahead, that that's going to end up being a quotient rule with a little hody-hi. So that's kind of the direction we're going. Let's see if we can make it there. The 3 comes down in front. Well, that's easy. Take the grouping to 1 less power. T squared plus 1 over 2t minus 5. Squared, because I'm 1 less power. But then I need to do the derivative of what's inside. That requires me to use the quotient rule. So I go, ho, 2t minus 5. D high, 2t. Minus high, t squared plus 1. D ho, 2. All over the bottom squared, ho ho. 2t minus 5 quantity squared. There's my setup for the quotient rule. And then what I'm going to do is kind of work my way with this. I'm not going to play with these 2 pieces. I'm not going to FOIL that. That's a nightmare. But this I need to simplify out a little bit better. So I'm going to take 2t times 2t, and I get 4t squared. I'm going to take negative 5 times 2t, I get negative 10t. I'm going to take t squared times 2, 2t squared, but it's negative. 1 times 2 is 2, but it's negative. And that's where I'm at for my first round of combining like terms, or multiplying out those pieces. So I want to combine like terms next. 4t squared minus 2t is 2t squared. And then a minus 10t and a minus 2. Now let's see if we can put this all together. So I'm going back to the beginning. I have a 3. I have this crazy fraction t squared plus 1. over 2t minus 5, quantity squared. And now I have a 2t squared minus 10t minus 2 all over 2t minus 5 quantity squared. Now there's all sorts of equivalent forms that this can be found as an answer. Like there's a lot of different ways that you can write this, but I'll give you some options. This is one option. Here's another option. All of these numerator pieces have a 2 that I can factor out. That's going to leave me with a t squared minus 5t minus 1. And Mr. 2 here can join up with Mr. 3 there, and they become 6. 6. I have, I'm going to keep everything the same for now. T squared plus 1, 2t minus 5, quantity squared. And then I've got a t squared minus a 5t minus a 1 over 2t minus 5 squared. So for that move, all I did was multiply the 2 and the 3, and they got 6. Now there's one last thing I can do to this. I can combine this to be all one fraction. The 6 is on the top. The t squared plus 1 is squared. That's on the top. The t squared minus 5t minus 1 is also on the top. And then I have a 2t minus 5 on the bottom. But how many do I have of that grouping? The grouping has this piece and this piece. Well, I can see I got 2 of those. And some people might say 3, 3, 3. There really isn't. There's really 4 because this grouping is being squared. So I have 1, 2, 3, 4. I have 4 powers of that thing. And that's my final best answer. How about that? That was a good time. All right, so we're going to go on and look at some more examples. If you flip the page, now I am looking at number 7. And number 7 says, okay, now find the derivative, but find it when x equals negative 3. And so what you want to write a note in your margin is, write a little note here that you want to plug the number in. Plug the number in as soon as possible. And you'll see what I mean as we get into this, because the more you simplify something, the more there's a chance for making a mistake. Like, let's go back to the last question. If they gave it to me and they said, okay, figure out what this is at, I don't know, x equals 1, t equals 1, you could just plug it in right here and not go through the extra steps of simplifying because you might make mistakes along the way. So if they said, figure out what it is when t equals 1, then you just would plug a 1 into all the t places and you can calculate out your answer. All right, so don't get too far down the road with these in simplifying them if you're going to have a number answer anyway. This one I see I have 2 pieces, right? They're being multiplied together. So my predominant rule is the product rule. And really to do this, it's going to be 2x, and then my other grouping here is going to be 1 minus x to the 1/2 power. All right, so if I do that, let's see, I'm going to product rule first. I can't plug this in until I get the derivative. So g prime of x, product rule, first times the derivative of the second, power rule, 1/2 comes down in front. The grouping goes to 1 less power. But wait, then you need the derivative of what's inside, and that would be a 0 and a negative 1. First times the derivative of the second, plus the second, 1 minus x to the 1/2 times the derivative of the first. All right, so you're looking at this and you're saying, well, am I ready to plug it in? And you could absolutely do that right at this place. So let's see what that would give us. We're putting in a negative 3. So in all the x places, well, actually I can do a little simplifying. This 2 cancels with the 1/2, right? That leaves me with a negative, I might just do one round of simplifying here, negative x and a 1 minus x to the negative 1/2 power. and I have a plus, and this guy is a 2, 1 minus x to the positive 1/2 power. All right, let's go for plugging it in. G prime of negative 3. So a negative, negative 3 makes this a positive 3. 1 minus a negative 3, that makes it 1 plus 3 is 4. The square root of 4 is 2, but it's a negative power, so that means it's in the denominator. So I have times a 1 over 2. Well, let me show you that one more time. 1 minus a negative 3 is 1 plus 3, that's 4. The square root of 4 is 2, and it has to go in the denominator because it's negative. Then I have the plus sign, and I have a 2 times. 1 minus a negative 3 is 4. The square root of 4, regular old square root of 4, is 2. So this is going to be a 2. And so let's figure this out. 3 times 1/2 is 3/2. 2 times 2 is 4. If I add them up, 1 1/2 plus 4 is 5 1/2. And that is my final best answer. Now with a chart, the kids that were in class said that the chart ones, these next ones coming up, are way easier. So let's see what you think. I have find the derivative for f prime of 4. And you're looking at the chart going, well, why are they giving me values for 3? What do I care about 3? And you'll see. It comes up. So I need to expand these first, and you saw this done in the last section. Expand these first using the rules that we know. So this one is a power rule. If I want to find the derivative, I'm going to take that derivative, I'm going to use the power rule. 2 comes down in front. G of x goes to 1 less power to the first power, but then I need to take the derivative of what's inside. Now in our case, we're looking for f prime of 4. So if I'm f prime of 4ing this, plug a 4 in, 2. Then I need g of 4. Then I need g prime of 4. Here's where your chart comes. 2 times g of 4 is 3. G prime of 4 is negative 2. Multiply them all out, you get negative 12. And there you go. For the second one, this one would be like h of x to the 1/2 power. You're taking the square root. We like to use it as a power so that my derivative, f prime of x, power comes down in front, 1/2. I've got to take the h of x to 1 less power. That's a negative 1/2 power. But then I need the derivative of h prime of x. My x value is 4. F prime of 4 is 1/2 of h of 4 to the negative 1/2 power times h prime of 4. So go to the chart. Equals 1/2. H of 4. H of 4 is 9. Okay, cool, 9. The square root of 9 is 3. Negative exponent makes it 1/3. 3 has to be in the denominator. Times h prime of 4, that's a 5. Technically it's a 5 over 1, so when I'm multiplying, 1 times 1 times 5 is 5. 2 times 3 times 1 is 6. And there's my final answer for him. All right, last one like this. Now this is going back to the original rule we started out with for composite functions. This, when I expand it, and you can go back and look at the front page, it's f of x, f prime of x I'm doing. F prime of x, you take h prime of g of x and multiply it by g prime of x. The outside, derivative of the outside times the derivative of the inside. And so if I'm looking at this guy at 4, plug your 4 in, f prime of 4 is h prime of g of 4 times g prime of 4. So for this guy, he's kind of a got two things going on here. I need to know what g of 4 is first so I can plug it in to get h prime. So h prime, go to g of 4. G of 4 is 3. Times g prime of 4 is negative 2. So this piece here, g of 4 is 3. Now I need to h prime of 3. That's why you got the extra row of 3 numbers. So h prime of 3 is negative 3. So now I've got, this is equivalent to a negative 3. This is times a negative 2. And they give me a final answer of 6. And that's how you're looking at a chart doing them, which is kind of cool. All right, I'm going to pick and choose some of our examples here, the practice problems for us to look at together. First one's number 4, and then we're going to do number 7 on this page. So number 4 is first. I tried to pick the ones that I thought were ugliest. So this one was the first one, and I don't like the form it's in, right? I don't like this because it's a square root, and we don't deal with square roots. Cosine of x squared. I need double parentheses here, because it's being raised to the 1/2 power. So I'm going to use the power rule like I've been doing. Y prime equals, the half comes down in front. I keep the group exactly the way it is, 4 minus the cosine of x squared, but I take it to 1 less power. That's a negative 1/2 power. But now I need to do the derivative of what's inside. Here comes my chain rule. Well, the derivative of 4 is 0, so that's fine. The derivative of, I'm just looking at this part now, the derivative of a negative cosine, well, the derivative of cosine is negative sine. So a negative sign makes it a positive sign. So now on the sine, keep the angle the same. And then I have to do the derivative of the angle, which is 2x. All right, then it's just a matter of cleaning it up and trying to make it pretty if it can be. The first thing I notice is that this half here can cancel with that 2. So they're gone. And I know I have a fraction because I've got a negative exponent there. So I'm going to make a fraction line. And I know that this whole hot mess is a square root that's in my denominator because of that negative power. So it's now back, I'm going to put it back as a square root. 4 minus the cosine of x squared, square root of that. Then I'm here. That doesn't have a negative power on it, so that stays in the top. Sine of x squared. And then I have an x that also is in the numerator. So x times the sine of x squared over that crazy square root. And that's the final answer for that guy. That's number 4. Number 7, I'm going to change that to be a power. Tangent of 2x to the 1/2 power. And apply the same exact power rule to him. So my f prime of x is going to be 1/2 tangent of 2x to 1 less power, negative 1/2 power, times the derivative of tangent, secant squared, times the derivative of the angle. You kind of know that you've got all these pieces because if you look back at the function, I have a square root function going on, I have a tangent function going on, number 2, and number 3 I've got a 2x going on. So there's 3 parts to that, thus why I've got 3 parts to this, right, in the chain rule. So however many functions you have, that's how many you're going to end up using derivatives of. So I have this, the half and the 2, they're gone. Again, I know I have a fraction because I've got a negative exponent. He's going in the bottom. He's a square root tangent of 2x. This guy's on top, secant squared of 2x. And that's your final best answer for him. Okay, try a few more and then we'll be done. I have number 13 is next on my list. 13. So this is an e. So we haven't seen e's for a little bit. I'm finding a g prime of x. This is still, just find the derivative as the directions that I've got. So if I do that, I have e's stay the same. E to the cosine of 7x cubed. By the way, how many functions do I have? I have an e function, a cosine function, and a 7x cubed function. I have 3. So here's piece number 1. Here comes piece number 2. Find the derivative of cosine, which is a negative sine, of the same angle, and multiply that by the derivative of the angle, which is 21x squared. And see if you can make that any prettier. I don't know that there's no fractions involved. I have no negative exponents. Normally the 21x squared would be your first piece, and remember it's negative 21x squared. And then I guess I probably would put the sine next, and then I would put your e piece last. Does it really matter? And the answer is absolutely not. Multiplication, you can put it any order that you want. I'm going to pick a couple from the tables, like I just showed you how to do on the note part. I'm going to try number 18 is my first one. And this one I am looking at these. I have a 2, a g of x, and an h of x. The 2g of x is all one piece. The h of x is a second piece. And what I'm going to do with that is product rule them. They're being multiplied together, therefore I'm going to product rule it. So I'm going to expand it first. F prime of x. Take the first times the derivative of the second plus the second times the derivative of the first. And so there's what your expansion would look like. Now we want to know, according to the directions, what it is for f prime of 5. So f prime of 5, 2 times g of 5 times h prime of 5 plus h of 5 times 2g prime of 5. And I'm ready for the chart. By the way, you can skip this first step that I'm showing. Excuse me, go directly to the second step. That would be okay too. 2 times g of 5. G of 5 is 9. Times h prime of 5, negative 4. Plus h of 5 is 5. 2 times g prime of 5 is 6. So I'm going to add, multiply these out. This is negative 72. This is 30 times 2, it's 60. Add them up, I get negative 12. That's my final best answer. Number 20. I have a g of h of x. Now again, remember how that expansion goes. So that f prime of x, the derivative is g prime of h of x times h prime of x. Just like the beginning of the notes, that rule that we wrote down. In our case, it's a 5. F prime of 5, g prime of h of 5 times h prime of 5. G prime. I need to know what h of 5 is first. So if I go up here, h of 5 is 5. So I want to put a 5 in that place. H prime of 5 is a negative 4. G prime of 5 is 6 times a negative 4 gives me a final best answer of negative 24. So there's a couple with a chart situation. All right, flip it again. We'll try a couple more. Here it is. 23 is next on my list. So 23 is here. You can see this guy's got all sorts of stuff going on. It's got the square root going. It's got this thing being cubed. And then it's got an x squared in here. So you've got like 3 different parts to this thing that are going to come into play. I'm actually going to start writing it over in this block so I have enough space to be able to put this in here. My phone is going off. It's snowing outside as I'm recording this, and school is calling. Do you think they're calling to tell me it's a snow day? Should I stop and see? No, I'll wait. I won't waste your time. Okay, I'm going to start writing over on the side here. So if I do that, That is going to be, remember square roots we don't deal with, so I'm going to change this to be 1 plus x squared minus 1 cubed, and that whole thing is being raised to the 1/2 power. Is that not a hot mess? And there's no way I can make that better. So I'm just going to go for it. I'm just going to do what I'm supposed to do. I'm doing f prime, and by the way, find the slope of the tangent line at the given x value. So this is one of those that we want to stop as soon as we can stop and plug a 2 in for whatever our derivative is going to be. But you got to get to the derivative first. So f prime of x, power rule is what I'm going to do, 1/2, and I'm going to keep this whole hot ugly mess just the way it is. Make it a 1 plus, and then the grouping x squared minus 1 cubed. But instead of this being to the positive 1/2, now it's to the negative 1/2 power. All right, I'm going to have a fraction. But then I need to multiply that by, now I'm just looking at this part, the x squared minus 1 cubed, because the derivative of 1 is 0, so I can ignore that. And I'm right over here to the next piece, the next function that I've got, x squared minus 1 cubed. So now I'm going to apply the product rule to that. That's going to be a 3, and it's going to be times x squared minus 1 squared. The power comes down in front, the group goes to 1 less power. But then I need to then multiply that by the derivative of what's inside. Now the derivative of what's inside is x squared 2x. All right, let me see what I can do. This 1/2 over here and this 2 can cancel. Woohoo! And I'm going to put the fraction together of what I've got. I'm not going to simplify any more. I'm just going to put the fraction together. I know this whole hot mess is in the denominator as a square root. Right? 1 plus x squared minus 1 cubed. And then the rest of what I have left has to be on the top. Don't forget this little x at the end. So there's a 3, there's an x, and then there's an x squared minus 1 that's being squared. That's my whole numerator. And then I'm ready to plug in a 2 for my x's and see where it goes. Now when I plug in the 2, that is the slope of the tangent line, right? Derivative is the slope of the tangent line. So I'm going to plug a 2 in. I've got 3 times 2. I have 2 squared minus 1 squared. On the bottom I have a square rooty, 1 plus 2 squared minus 1 cubed. Please excuse your dear Aunt Sally. So 4 minus 1 is 3. 3 squared is 9. 3 times 2 times 9 is my up top. Let's keep going with him. I end up with 6 times 3, and that's 54. All right, let's talk bottom. 2 squared is 4. 4 minus 1 is 3. 3 cubed is 27, and 1 more is 28. Square root of 28. Well, guess what? You can tree this thing from back in the day and simplify this to a better square root. Pick any two numbers. I don't know, 4 times 7. So you end up with 2 times 2 times 7. Anybody with a buddy can come out. So I got 2 square roots of 7 from back in the day of algebra. And the final best reduction, the 54 on the outside and the 2 on the outside, they can both be reduced. So I end up with 27. 27 over the square root of 7. And that, my friends, was number 23. Almost done. If I go to 26, that one's next on my list. 26, change up the directions. Find the equation of the tangent line at this given x value. So my given x value is pi over 4. I need a point and I need a slope. If I need a slope, then I need a derivative. And this one, before I even derivative, I'm going to look at it as being the sine of 3x squared. Now again, I'm going to go left and start my box over here. Start over here so that I have space enough for you to see it. So y prime. The 2 comes down in front, power rule. Take the grouping to 1 less power, sine of 3x, goes to the first power, times the derivative of sine which is cosine of the same angle, times the derivative of the angle, which is a 3. Can I make it any better? And the answer is just a little. 2 sine of 3x. Actually, not 2, it's 6. 2 times 3. I can make that one go together. The 2 in the front, the 3 in the back. Sine of 3x, cosine of 3x. Well, they told me that I need to know what it is when it's pi over 4. So I'm going to put this in as a pi over 4, my x's. Y prime, so I'm trying to get to a number here, right? I'm trying to get to a slope that's a number. So 6 times the sine, 3 times pi over 4 is 3 pi over 4. Again, cosine of 3 times pi over 4 is 3 pi over 4. So I have to go around my unit circle to 3 pi over 4, and I'm going to think about that for a minute. 3 pi over 4. Some of you have that handy-dandy chart that we did way back in the day. So you can kind of peek on that too. But if I'm looking at 3 pi over 4 on the unit circle, it's over in the second quadrant. So if it's in the second quadrant, it's a negative x and a positive y. My pi over 4s, any of the fourths, are square root of 2 over 2's for both of those. All right, so what does that look like in my case? Y prime is 6 times the sine of 3 pi over 4 is the y coordinate, square root of 2 over 2. The cosine of 3 pi over 4 is the x coordinate times a negative, square root of 2 over 2. What the heck is all that? Well, 6 is over 1. Square root of 2 times the square root of 2 is 2. 6 times 2 is 12, and it's negative. 1 times 2 is 4. I get a negative 3. Out of that whole hot mess, I get a slope that's negative 3. How about that? Well, I'm working towards making the equation of the tangent line, so I also need a point. Well, I'll go back to the equation. My equation is here. I've got this. I'll just keep going with this. I'm trying to figure out in my point, I know that the x value is pi over 4. I don't know the y value, so that's what I'm working towards, the y value. My y is going to equal the sine of 3 pi over 4 squared, right? Because x is pi over 4. So the sine of 3 pi over 4, and then I'm going to square it. Well, we said the sine of 3 pi over 4 is the square root of 2 over 2. So I'm going to take the square root of 2 over 2, and I'm going to square it. That's going to give me the square root of 2 squared is 2. 2 squared is 4. 2 over 4 is 1/2. There is my y value. So now I have a point, and I have a slope, and it is easy peasy, lemon squeezy to put your tangent line together. Y minus 1/2 equals a negative 3 times x minus pi over 4. And there's your tangent equation. And then the last one, do a little happy dance. Last one I'm going to do is 27. 27 is one of your test prep questions, but I thought it was kind of hard. I think if you read it, you'd be like, what on earth are they asking me to do? So the graph of the function f is shown. The function h is defined by f of 2x squared minus x. See how this is a composite function like we've been working on in this section. Find the slope of the line tangent to the graph of h at the point where x is negative 1. And you read that and you're like, like, where do I go from here? Well, what you want to do is you want to find the slope, you want to find the derivative. So you really are looking for h prime of x. Well, here's h of x. h of x is this. This goes back to what we started the lesson with, and how do you expand that into the derivative rules? So it's going to be f prime of 2x squared minus x multiplied by the derivative of what's inside. The derivative of 2x squared is 4x. The derivative of negative x is minus 1. All right, so now I want to know, they gave me the x value, right? H prime of negative 1. Let's see what that looks like. F prime of 2 times negative 1 squared minus a negative 1 times 4 times negative 1 minus 1. Plug in your x's, right? Let's see where that takes me. F prime of negative 1 squared is 1. 1 times 2 is 2. 2 minus a negative 1 is 2 plus 1. That's a 3. Times. 4 times negative 1 is negative 4. And negative 4 minus 1 more is a negative 5. And you say, well, that's great, except what the heck is this? F prime of 3. Well, here's the graph of f, right? F prime is the slope. Can you tell me what the slope is at 3? Well, the slope of a straight line doesn't change. You just need to figure out what the slope of that line is. So find some pretty points. Find some points that go through perfectly. Like right here and right here. We're going to use those 2 points. And figure out the slope. The slope of that line, it's going to rise 1 and go left 2. So see how it's a negatively sloped, nice, negative, remember slopitude? It is a negatively sloped line. So it is going to be a slope of negative 1 over 2. So this is the slope at 3, and you say, okay, I got that from the picture. It is a negative 1/2. Multiply that by a negative 5, and you get a positive 5/2, and you have just answered their question, what is the slope of the line tangent to h at x equals negative 1? Okie doke. So, you are set free to answer the rest of the questions that go to number 31. If you have questions or run into a jam, shoot me an email and I will get back to you. So otherwise, I will see you in class. Have a good one.